Welcome to our lesson on solving inequalities. In this lesson, we're going to talk about solving linear inequalities and compound inequalities. So let's get into it. We're going to graph some inequalities on a number line, so we're going to review how to do that. So when graphing inequalities, we're going to use closed circles or we're going to use open circles. We'll use a closed circle whenever we have a less than or equal to, or a greater than or equal to. So if we have that line underneath it, we say that value is included, and we're going to indicate that on the number line with the closed circle. We also could use a less than or greater than without the line underneath it. In those cases, we say that value is not included, and we indicate that on the number line with an open circle. And now when we write our solutions for these questions, we're going to start using what's called interval notation. Interval notation, you have parentheses and you have brackets. With parentheses, that's going to indicate numbers that are not included or if it's an open circle. Remember, our parentheses will just look like this. Brackets do the opposite. Brackets kind of the default. It represents included or closed circles. And brackets, we use like these square brackets like that. So now let's practice graphing a couple of these equations on the number line. So now we're going to plot x is greater than or equal to 8. So whenever we're graphing these inequalities, the first thing you want to plot is 0. And then you can just plot whatever number that you're given. So in this case, 8. And just make sure it's on the right side of 0. And so we want all the numbers that are greater than or equal to 8. So that means I'm going to put a closed circle on my 8. And then I can highlight all of these values to the right of 8 because all of those values like 9, 10, 11, all of those to the right are going to be greater than 8, which is exactly what we're asking for here. We can also write this in interval notation using our parentheses and brackets. And so we're starting at 8, and 8 is included, and so we use that square bracket. And then we go on forever and use all the values to the right. How we say going on forever in math is infinity. And so we're going to use that infinity, which is just a sideways 8. And we're going to always use a parentheses around infinity, since you can never touch an infinity amount of something. Let's do one more. Now let's do x is less than -1. And so I'm going to plot 0, and I'm going to plot -1 to the left of 0 this time. And since we don't have the line underneath the -1, I'm going to use an open circle at that point. And then I want all the values less than -1, which is going to be all the values to the left, like -2, -3. All of those are further away from 0, so they're smaller, aka less than. And now let's write this in interval notation. And to do that, we're starting, if we look to the left, we're going down forever. We're going to the left forever. The way we would write that is going to negative infinity. And then we're stopping at this -1 value. But since that -1 has an open circle and it's not included in our set, we're going to use another parentheses around -1. So now we're going to practice solving some of these. But there's one important rule that we're going to have. When solving inequalities, we're going to follow the exact same steps as we would if we were just solving a regular equation. The only thing that's going to be different when we solve inequalities is if we multiply or divide both sides by a negative number, we're going to have to flip the direction of the inequality. Okay, so let's do a couple of examples. So here we have 5x plus 1 is greater than 7x minus 17. So let's do this how we regularly would. First, I'm going to look, are both of my expressions simplified? Well, I don't see any parentheses or like terms, so I think I'm good to move into step 2, where I'm going to get all of my variables on one side and all of my constants on the other. And so to do that, I'm going to move my smaller variable, which in this case is the 5. And when I move it, I need to subtract it from the other side, which means that I need to move, since all my variables are going to be on this side now, I need to move this 17 over. And to do that, since it's negative, I'm going to make it positive and add 17 to both sides. So now then these 5x's cancel, and I'm left with 17 plus 1 will give me 18 is greater than 7x minus 5x would leave me with 2x's. Now to get 1x by itself, I'm just going to divide 2 on both sides. And so then those 2's cancel, and I get x. And on the on the left, I get 9. And I'm just going to reverse this around so it looks a little more normal for us. So I say x is less than 9. Okay. Now let's graph this on the number line to see what it looks like. So I'll draw my number line like this. I have 0 and 9 would be out here. Since I don't have that line underneath the inequality, I'm going to use this open circle around 9. And I want all the values less than 9, so that would be numbers like 8, 7, 6, all the way down to 0 and beyond. So that would be all of these values to the left of 9 like that. Okay, now let's also write our answer in interval notation. Since I'm going left, or since I'm going down forever, we call that negative infinity with the sideways 8. And I come all the way up to the value 9, but I don't actually touch 9 since I have that open circle, which just means I'm going to end at like 8.99999 repeating. And so these would be my that would be my answer written in 2 different notations and on the number line. Let's do another example now. So let's go ahead and simplify both sides of our, or both expressions that we have. On the left-hand side, I see I have this negative outside of parentheses. So I'm going to distribute that negative 1 to the inside. First, I'll bring down my 3. Now, negative 1 times 4x would give me negative 4x and minus 4. Sorry, minus 1. And that's going to be greater than or equal to 5x minus 25. And now I'm still simplifying the left-hand side because I've got this 3 and this minus 1 here. So I can combine those and say 3 minus 1 would give me plus 2. And that's going to be greater than or equal to 5x minus 25, which is already simplified on the right. Now that everything's simplified, I can go about getting my variables on one side and my constants on the other. So I'm going to subtract this 5x from both sides, which means I need to move this 2 as a constant to the other side. And I do that, I will subtract it. Negative 4x minus 5x will give me a negative 9x. And that's going to be greater than or equal to negative 25 minus 2 will give me a negative 27. Now we can get the x by itself by dividing by negative 9 on both sides. Oops. Divide by negative 9 on both sides. When we divide by negative 9 on both sides, those x's will cancel out. So I'm left with x. And now we have to be careful because we just did something very important. I just divided by a negative 9. Remember when we said at the very beginning, if we multiply or divide by a negative number, we have to flip the inequality. So that means instead of greater than or equal to, I'm going to have less than or equal to. And negative 27 divided by negative 9 will give me a positive 3. So now let's graph that on the number line. I've got 0 and then 3 would be over here. Since I have the line underneath it, I'm going to include 3 in my solution set. So I'm going to indicate that on the number line with a closed circle. And I still want everything less than 3, which we know is to the right of 3. So I'll highlight all of these numbers here. And to write this in interval notation, like we have been, we're going to start by going left to negative infinity, right? We're doing all the numbers to the left of 3. And we stop at 3. And since we are including 3 in my solution set, I'm going to do the bracket around 3 like that. So here's my answer written in 2 different notations. The last thing we're going to talk about in this video is called compound inequalities. What compound inequalities are is that it's essentially two different inequalities in one. And so we're going to have two different solution sets, two different ranges of x values that will satisfy our inequalities. So there's or statements and there's and statements, and we're going to look at one of each of those. So let's do the or statement first. So here we have an or statement. We have the first one is 6 minus 2x is less than 8. Or we have x over 2, and I can write this 2 a little better maybe. X over 2 plus 1 is less than negative 2. So let's go ahead and do this. We're just going to solve each of them by themselves. The good thing is in either one of these, I don't have any simplifying to do. So let's focus on this first one over here. I've already got all of my variables on one side, so I'm going to move this this 6 over by subtracting it. And so I get negative 2x is less than 8 minus 6 would give me 2. And now I can divide by negative 2 to get those 2's to cancel. And remember, I'm doing that really important thing where I divide by a negative. I need to flip that inequality. So now we get x is going to be greater than 2 divided by negative 2 would get me negative 1. Okay, so we have that. Now let's go ahead and slide over and do this second half of my inequality. And so I start by subtracting the 1 to the other side. Since all my x's are here. So I have x divided by 2 is less than negative 2 minus 1 would give me negative 3. And now I have x being divided by 2. The opposite of division is multiplication. So I'm going to multiply both sides by 2 to get x is less than negative 6. And here I don't have to flip that sign or that inequality because I'm multiplying by a positive on both sides. Okay, and now we're going to graph these two on the same number line. So I'll do it like this, and I'll put 0 in the middle. Actually, you know what? Let's slide 0 up a little bit, so 0 will be here. Then I'll have negative 1, and then I'll have negative 6. And now I'm just going to graph each of these. So starting with x is greater than negative 1, I'm going to put a open circle around negative 1. And I'm going to highlight everything greater than negative 1, which would be all the values to the right. And now I'm going to do the same thing with x is less than negative 6 here. I'm going to put an open circle around negative 6. And I'm going to highlight all of my values that are less than negative 6, like negative 7, negative 8, negative 9, and so on. So I get these two ranges that I have. And so now I'm going to write this in interval notation. And so what we're going to do is basically write two different intervals, one for this and one for this. And so starting on the left, I see that I'm going down to negative infinity. And I'm coming up and stopping at negative 6. And that negative 6 is not included, so it gets a parentheses. Now, the way to write or in interval notation is just to have this big U like this. And now I can do my other half, which is negative 1 in parentheses, since it's an open circle. And then we go up to infinity like that. So that would be how I write this in interval notation. So I have my inequalities and interval. All right, we got one more problem to work, and this time it's going to be an and statement, and we're going to write it a little differently. Okay, so this is an and statement here, and we're just writing it all as one. And so you can really only do this for and statements, but we're saying that 3x plus 4 is in between 4 and 19. And so we're going to solve this just all at once, trying to get the x by itself. And so the first thing I want to do is subtract this 4. And when I do that, obviously these 4's cancel out here. But what I do to one side, I need to do to the other side. But here we have like 3 sides. So I'm going to take this minus 4 and I'm going to do it on all three parts of my inequality. So on the left, 4 minus 4 would give me 0. Then I have that's less than just 3x is less than 19 minus 4 would give me 15. And now I can just divide by 3. And just like on the last step, I'm going to divide by 3 everywhere. 0 divided by 3 is still 0, which is going to be less than 3x divided by 3 will just leave me with x. And then 15 divided by 3 will give me 5. Okay? And so now let's see what this looks like on the number line here. So I have 0 and I have 5. And so what I'm going to do is, make these separate again. I don't have the line underneath either of my inequalities, so I'll put open circles around those like that. And now we want all of the x values greater than 0 and less than 5. So what we can do is just highlight this in between here, because all of those numbers like 1, 2, 3, and 4, they're greater than 0 but less than 5. So that would be my my number line there. And last, for my interval notation, the leftmost value I have is 0. And I'm going to use the parentheses around that since we have the open circle. And then the rightmost value I have, it stops going right at 5. And I'm going to use another parentheses there. And so my interval is just between 0 and 5. And here's my inequality. And so we've solved this solved this inequality and written it in two different notations. Now, I hope you've had as much fun as I have solving these compound inequalities. Good luck in your practice, and I'll see you in the next video.